Ladies and gentlemen, let me present to you the one and only James, the Decomposer and the Synthesizer of Math and Science Tutor. Yeah, Bafetu, I'm back. It's such an honor, Bafetu, once again to be here. Let's take this moment just to thank God, if it wasn't for God's grace and His mercy, guys, I don't believe that gave it really far, you know what I mean? So Bafetu, guys, it's been a while, I've been on the field. Yeah, I can see, but it's good to be back. Remember, all the time, God is good. And then God is good all the time. All the time, God is good. And you know it, right? Okay, just keep it like that. Just keep it like that. Okay, guys, so I'm back on mathematics. Which part of mathematics? Partial fractions. So in my first videos that I've uploaded, I've posted, guys, I started with integration, basically integration by parts as well. Yeah, I'm still gonna do more video. I'm still gonna upload more videos of integration by parts so that you can see more methods, how to tackle those problems, you know what I mean? And I've also done the partial fractions. I remember the introduction to partial fractions, and I did one problem. I explained what a partial fraction is. You can check those previous videos. I've explained that we have you're gonna come across different types of fractions, basically the one that is improper, the one that is proper, you know what I mean? And how do you deal with the proper? How do you deal with an improper? So they are reducible, irreducible fractions, and how do you deal with them as well? So I've explained, if you can look at the first video of partial fractions, you'll see that. Okay, so there were two exercises or two questions that I've placed there, and I didn't do them, but I did the first one. So my apologies for that, guys, because of then from there I had to be preoccupied by other things. So but I'm back here. I just want to thank God. Bafetu, don't forget to comment, don't forget to subscribe, Bafetu, share these videos, Bafetu, and your friends and anyone who might be in need of this, Bafetu. Well, it might be good, I know, you know that, right? But if there are people out there who are actually in need of this, Bafetu, let's give them this, Bafetu, this platform. Things can be decomposed furtherly, so you know what I mean, and things could also be synthesized in different ways. That's why we have God who has given us people like us who are here to help you guys, you know what I mean. Linda, there were people who were there for me when I didn't really know this stuff, because I wasn't born with partial fractions in my brain. I had to learn them, and there were people who were there to guide me and all that. So Lynn, I'm also here to mentor other people, to help other people who are actually in need of this. So I hope you guys are ready to go with me to take you through the partial fractions. Are we all on the same page, Bafetu? Are we all on the same page, Bafetu? Okay, stay tuned, Bafetu, stay tuned. Let's get this. Let's rock this, Bafetu. Oh, by the way, it's a Man City, Bafetu. Leskelan Duma. Don't bite me, Bafetu. Yeah, if you're an Arsenal fan, Liverpool fan, United fan, just know that I love you guys, okay? When I'm doing math, we don't take things too personal. We are friends here, alright? But they, Okay, let's get back. So, now we have this problem. And then you're gonna ask yourself a question of, how am I gonna deal with this problem, Mr. James? My guy, here's a thing that I would like to show you. I'm just gonna use, I know people prefer to use different colors, basically. The more they use different colors, the more they, so yeah. Okay, I'm just gonna go with what? I think I'm gonna go with brighter colors for now. My apologies. Alright, good stuff. So remember, it's partial fractions. How am I gonna deal with this problem? How are you gonna decompose it, guys, basically? So guys, what we are going to do now, remember this is integration, remember this is in the integral sign. On the first video, by the way guys, I mentioned that if you see a sign like this, and let's just say this is f of x dx, remember that yeah, I mean, now you know with drawings I'm not really that good, I'm not gonna lie to you guys, even my handwriting is not that good, but yeah. So this is an integral sign, okay? This is what we call an indefinite integral sign. An indefinite integral sign, meaning after integrating, you're gonna have what? You're gonna have that f of x something plus c. I'm just saying, right? You're gonna have that f of x something plus c. You know, you have a constant there. When you differentiate this, it takes you back. So remember that integration is the opposite of differentiation. Differentiation is the opposite of integration. Okay, I'm still gonna do more videos for differentiation as well. So you can also check me out on TikTok, Buffet too. You will see more videos on differentiation basically. So yeah, now if I have a to b, you know, so we have lower bounds and upper bounds. You know, this is the lower bound, this is the upper bound. So meaning if this is what you call definite integration or definite integral sign. So there are two types of integral sign: definite and indefinite, whenever these two are not there. So please, I hope today you are all knowing this, if you didn't know that, right? Good stuff. So meaning after integrating, what are you going to do? You're going to have f of b minus f of a, and then you're going to get the value there. Understand? So meaning if here was, you integrated this and then you got the value was x, right? Let's just say you integrated and then the value was x. So meaning you're gonna say what? You're gonna say, and then if here it was what can I say, 0 here? Can I say 1 here? Allow me. So meaning I'm gonna say here on my b, which is the x right here, my f of b, which is gonna be my 1, it's gonna be 1 minus my 0, which is my f of a. Then what is 1 minus 0 is going to give me 1. So meaning at the end of the day, I'm going to get a value. So what is the difference between integral, the integration of definite and integration of indefinite? With integration of definite, the one that has the lower bound and the upper bound, we're going to have a constant at the end of integration. Hello? Good. Now, whenever you are having the indefinite in which you don't have those upper bounds and the lower bounds, we are going to have a function at the end of the day. Hello? Okay, please keep that in mind. There's still going to be more videos I'm going to upload, guys. So don't stress yourself and be like, oh my goodness, what am I going to do here? Well, I got your back. Hello, I'm back on the game, all right? Good stuff. So let's continue with it. Lovely. So now, we are having this problem now, and how are we going to work it out? Okay. Then we're going to have, I can say, this implies that we have x plus 35 all divided by. Now, the first question that must come to you, oh, sorry, Bafethu, this is x squared. I'm like, what's happening here? Hi, Bafethu. So we are having the fraction, and in which we have the numerator, the denominator. I've also explained in those previous videos, please check them out. So now check, are we having a proper or improper? Take a moment, just pause and check if it's an improper or a proper. What is the answer? 5, 4, 3, 2, 1. Okay, now the answer is that we are having a proper fraction. Remember when you are having p of x over q of x. Okay, so this is known as the numerator, this is known as the denominator, guys. So on the numerator, if the value is x cubed and the denominator, the value is x, which one is greater? The numerator. When the numerator is greater than the denominator, meaning when p of x is greater than the q of x, guys, this is what we call improper fraction. We're going to have an improper fraction. and in what? And an improper fraction. But whenever we have q of x becoming greater than p of not that, but p of x, in which, let's just say now our q becomes x squared, and then our p becomes x. Do you see that this one becomes greater than this one? You look at the exponents, here it's 2, here is 1. So that means we're going to have a what? A proper in this case, a proper. So I hope now you're going to have an answer of what type of this fraction could be. Guys, if we could be able to can identify this type of things before you just go straight, I'm telling you, you're going to be 100% fine with partial fractions. Believe me, integration won't trouble you them as much as it used to. You understand? Good stuff. Now let's go off it. Let's go. All right, so I can see that this one is a proper fraction. All right, now the question is the proper, because this one is greater than the numerator, the denominator. Now, am I having a linear or am I having a quadratic? Now when you look at this, it's a quadratic expression, hello, but a quadratic expression that can be what? Reducible. Whew. You must focus on that. The moment you are coming across this, you must focus on the denominator now, because it's a proper. Check this if it's a linear. Can I get linear factors or quadratic factors? Quadratic factors is the one that you can't even reduce. It's irreducible. Like, you know, the one in which you have to use the quadratic formula and you get, the answer is going to be 1 minus root 7 over maybe what? You got something like that, you know? You're gonna end up getting like decimal numbers and all that. When you're using completing the squares or quadratic formula, basically, yeah. So those are irreducible quadratic functions. So this one is a reducible quadratic. So this reducible quadratic, let me tell you something. It gives us linear factors. It gives us linear factors. Meaning that I'm going to reduce this into a linear factor. We remember that a linear is in the form of y equals to mx plus c, or y equals to ax plus b. This is linear, one way or the other. If we so, just know, alright? Don't be stressed. And quadratic is when you have ax squared plus bx plus c, or you have ax squared plus q, or you have a into x plus p or minus all to the power 2 plus q. All these are the forms of quadratic. You see that this one is this type of form. The a is the coefficient of x squared, which is 1 here. Hello? So don't be like, where is the a? I can't see the a. Okay, the a is 1 there. Don't stress out, okay? Just relax a bit. I'm here to give you the medicine of how to deal with partial fractions. Thank God for that. Okay, now let's reduce it to linear. So I'm going to take this quadratic and reduce it to linear. But how? I'm going to make use of the skills of algebra. Hello? Now guys, there is so-called factorization, okay, which you're going to basically find it under algebra. Factorization is when you're going to find the factors that made up that certain expression. So if I'm having this, remember what's my name? James the Decomposer. So when I factorize, I decompose because of I break something into different parts, into pieces. So when I factorize this, I'm basically decomposing this. Hello? Okay, let's factorize it. So if you wanna say James the Decomposer, you can say James the Factorizer mathematically. That one is for chemistry and all that. Yeah, okay, let's come back. Now, let's see. Can I reduce it? Alright, so I'm gonna have what? X minus, you can say x plus 5 into x minus 5. Okay? Dx. Don't forget dx, okay? So we have this now. I was able to get what? To can factorize it. But how did I factorize it? Okay, basically there are 4 types of ways in which we can factorize. The first one is to find the common factor. Secondly, you must find the difference of 2 squares, which is what I've applied here, the difference of 2 squares, okay? Thirdly, it's trinomial, where the one in which you need to find the factors, you know, using quadratic formula, completing the squares, or just using factor theorem in J. And then the fourth one is grouping, by grouping. Okay, so yeah, those are 4 ways in which you can factorize. Yeah, from the foundation of lower grades, grade 9, grade 8 stuff. No, basically grade 9, that's where you learn to factorize, right? Good stuff. But let's get back here. So now, how am I gonna deal with this? So now we have this. Allow me that this implies that okay, basically this equals to this. I'm sorry. Now this implies that x plus 35 all over x plus 5 into x minus 5 dx equals to the integral sign of what? Of or the integration of a. Now we are breaking them. Now we are breaking them, Bafethu. Please keep this in mind. Though. We are breaking them. So it's going to be a into x minus x plus 5. Okay. Plus b over x minus 5 dx. Basically, this is what we are having. It's a linear. Remember, if you check the first video of partial fractions, that's what you have. When you are having a linear factor, this is what you do. If it was a repeating factor, for example, you had like 1 over x minus 2 all cubed. This will be a over x minus 2 cubed, alright, plus b over x minus 2 squared plus c over x minus 1. Oh, sorry, x minus 2 there again. So because of its cubed, how many x minus 2 must we have? There must be basically 3. So we are reducing it to linear. So 3 minus 1, it's 3 basically. We started from 3 and then you reduce it by 1, 2. The last one. 1 2 minus 1, that gives you 1. So we have that's what you call a repeated linear factor. So it's a linear factor that is repeating itself. Now there is also a quadratic factor that could repeat itself. There could also be a quadratic that is irreducible, in which when you actually decompose it, it's going to give us, let's just say we had x plus 25. X squared plus 25. Okay, this one is not the difference of 2 squares. So I cannot have the factors like this. So what am I gonna do with this one? So with this one, if it was over 1, excuse me, and then from there, what's gonna happen? Ax plus b over what? X squared plus 25. I'm just trying to give you like an example because it's irreducible. This is how quadratic will be. Quadratic, you will see, Buffett. You will just see, like it's too much. You will see as we go further with this. So now, what do? We are going to apply this now. Allow me, Buffett. Allow me. So let's make use of this. So I'm gonna say this implies that we're gonna have x plus 35 over x plus 5 into x minus 5 minus 5, which equals to, I can take them out of the brackets because I need to find the value of a and b, right, so that I can finally integrate it nicely. So, and then I'm gonna have a over x plus 5 minus plus b x minus 5. This is b of a2. And there we go. Then what do we do from here? We need to reduce this fraction. Okay, we need to pull it down. Let's pull it, let's apply the force of gravity. Come down. So what happens here? We need to find what you call the LCD. So basically you can see it's just what the denominators here. It's your x plus 5 into your x minus 5. Your LCD is basically the denominators, guys. When you multiply the product of the product of your denominators, basically either your LCD, right? It's going to be the one that you're going to use to multiply on each and every fraction. So please keep this in mind. When I take x plus 5 times x minus 5, I multiply it on this fraction. What's going to happen? This one will cancel with this one. This one will cancel with this one. This one will cancel with this one. Then I'm going to be left with what? With x plus 35 equals to. Now, when I use this and I multiply on the fraction a over x plus 5, what's going to happen? X plus 5 goes with x plus 5. Then I'm going to be left with a into x minus 5. Okay? Then again, what's going to happen? I'm going to have plus. When I multiply this LCD on this fraction of b over x minus 5, x minus 5 goes with x minus 5. I'm going to be left with b into x plus 5. There you have it. There you go. Okay, so guys, now when you are actually at this point, there are two ways you can. There are many methods which you can actually do to can find the value of a and b. I'm just gonna use two ways. Ne? So the first method you can use, you need to check. You see here it's x minus 5, x plus 5. So how about we let first x to be equal to 5 and find the values there. So if I let x to be 5, what's going to happen? So it's going to be 5 plus 35 equals to a into 5 minus 5 plus b into 5 plus 5. Then guys, check it out. This is 0 at the end. And this one will give me 10b. And then this one will give me 40. Guys, if ever you check, if you divide, it's fine. I'm gonna allow me to erase this part here. Let me erase this part. Give it enough space. I'll just reduce this space of it. It's not a problem. Just to have space. You guys must be able to see. Okay. Now it's 40, and then it's basically 0 plus what? Plus 10b. How did I get 10b? 5 plus 5 is 5. 5 plus 5 is 10, and then 10 times b is 10b. So that's how I got it, right? And then from there, check this out. I'm going to have 40 equals to 10b. Now, when I divide both sides by 10, I'm going to get my b to be 4. So if you got your b to be 4, please give yourself a round of applause. Well done. So I got my b. Now, how about now and, just say and. And again, you let x to be minus 5. So the first one we started with x equal to 5. What about now when we make it negative 5? So I'm going to still apply the same thing to find the value of a. So it's going to be minus 5 plus 35 equals to a into minus 5 minus 5 plus b into minus 5 plus 5. Okay, let's make use like this. And then check it out. I'm going to have 30 equaling to, it's going to be minus 10a plus 0 basically, then 30 equaling to negative 10a. Negative 10a, and then my a will be equaling to what? Negative 3. So if you divide 10 by 30, negative 10 by 30, you're going to get negative 3. Please use a calculator. They will use their brains, and then they will be like, 10 divided by 30. It's going to be 30 divided by 10. Oh, yes, it's 3. You got it right. No, it's wrong. Why? You know what you did, right? You forgot the sign. Sometimes you don't fail because you don't know. We fail because of silly mistakes like this. So let's avoid such mistakes, perfect. All right? Just use a calculator for making sure. I know that you might trust your brain and all that, but sometimes you might be a bit sloppy. You're a human being. You get what I'm saying? Awesome. Then we got our value of a, it's negative 3, and our b is what? Is 4. So that is the first method that we can use to find the value of a and b. What is the second method? It's up to you. Which one do you like? Okay. This mathematics you see now, this problem we need our goal was to find the value of a and b. Fine. But this is the first method, meaning that my point is that we all got different beliefs. So if you believe in something that's going to work for you in life, believe. Don't let anyone, you know what I mean? Just believe in, make sure, you know what I mean? So if you believe in God, believe in God. If you believe not, bow now, guys, whatever that you believe in and you know that it's working for you, do so. But God will never leave you nor forsake you. Trust him, okay? Okay, but fair too. Let's come back. Let's use a different method. Yeah. Method will teach you that in life, you can still go anywhere else. As long as when you believe, born, and you're determined. But if my determination is strong enough, failure will never what? Overtake me. Keep that in mind. Okay, let's continue, Buffett. We know our B was 4, our A is -3. So to use a different method, we're gonna do this. It's gonna be x 35, A times x, AX, minus 5A plus BX plus 5B. Okay, now from there I need to combine the like terms. So I'm seeing x plus 35. This could be AX plus BX on the same part, minus 5A plus 5B. Then check what I'm gonna do now. Because these ones are the same, they look like x. I'm gonna say x equals to x into A plus B. So what I did, I took out x as my common factor. Hello. And then another part, you can just say, let this maybe to be your equation 1. And then another one, you can just say 35 equals, because it's, remember these are constant. You see, it does not have x, they don't have x, so they are constant. So they'll all equal to 35. So it's gonna be minus 5A, minus into 5 plus. Any it's fine. Even if you say 5 minus A plus B, still okay as an equation 2. Still fine. Then from here, check what I'm gonna do. We divide both sides by x, then 1 equals to A plus B. Then if I want A, my A equals to what? To 1 minus B. That's my equation 3. Then I'm going to substitute my equation 3 into equation 2. If you don't remember simultaneous equations very well, please go to TikTok and find James the Decomposer. You'll see the simultaneous equation in terms of using elimination, using substitution. Ne? It's a foundation. It's a foundation. I'm not going to leave you behind. Sihamba sonke. Anyethi bafethu. Siyakhala manje. Then what happens? What happens is that I'm gonna simplify this further. Okay, basically, if you divide both, you're gonna get what? Divide. You're gonna get 7. You're gonna get 7, which is gonna give us minus A plus B. This is still equation 2. So I simplified this one further. What did I do? I divided both sides by 5. Then I got 7. But 55 times 17 is 35. Remember the mentals just 5, just 7. Okay. Yes. The times table song. Yeah. So then from there, what happens? I'm gonna have, where I see my A, I'm gonna put it. So I'm gonna say 7 equals to minus into 1 minus B plus B. You see, where I see A, I'm gonna put 1 minus B. The negative sign is still outside. Please. Then from there, negative times positive, negative. Negative, positive B plus B equals to 7. Then from there, 7 equals to minus 1 plus 2